Happy Monday. Video number 3 in my absence. I will be back tomorrow. All right. TCAP prep for Monday. Number 1, use the diagram to answer the question that follows. One benefit provided by the machine shown in the diagram is that it, what do y'all think? He's pulling down, the box goes up. The best answer is A. It changes the direction of the force. Remember, force is a push or a pull, and he's pulling that rope. Number 2, which section of the earth is composed primarily of liquid metal? Now, you may have looked in your notebook for this one. Maybe you remember, but we have, all of these are real layers of the earth, so you really have to pick one. The inner core is a solid, so that's out. The crust is a solid, and I think we would know if where we lived was a liquid metal. We wouldn't live here. That's out. So you have mantle and outer core. Mantle, if you remember, it's like plastic. It is the plastic-like layer. We have never said it was liquid. We have never said it was metal. The outer core is liquid metal. And if you look on, you have a Layers of the Earth foldable that we did way back in like October, November. It's in there. It's in your, it's kind of like a multi-flat sheet thing. Oh, you know what? I'll get mine out. I'll show you. I'm getting there. Hang on. Rock cycle. Where are you? Layers of the Earth foldable. Was that upside down foldable? Outer core liquid. Hold on, just the wrong one. Outer core is a liquid. The core is 33% of the Earth's mass. It is mainly composed of iron. That's a metal. It's a liquid. You could have looked here. Maybe you just remembered. I don't know. Hopefully, one of those two things worked for you. Due to extreme pressure, the inner core of the Earth, boom, right there, probably your own handwriting on your own foldable, the inner core of the Earth is a solid. Which layer of the Earth makes up the smallest percentage of the Earth's mass? Well, it's where we live, the crust. Oh, I haven't done it. So this is A, this is C, A. All right. Number 5. Students are learning about the different types of waves. Which is the least likely way for students to generate a wave? Moving particles, adding energy to particles, and those particles responding in movement. Tossing a ball in the air, shaking the ends of a rope, throwing a pebble into a pool of water, pulling on a coiled spring toy. Why do you think they gave you this one and this one? I guarantee you it's because I bet teachers in the state of Tennessee used a long rope and used a coiled spring to demonstrate particle movement in a wave. But what do you think the best one is? Where you're adding energy. Let's see. Throwing the pebble into a pool of water. This one makes me sad. If the state really goes for it, they're picking on the way that I teach, and they're using it against you and me, and I don't think that's fair. The right answer is C, and I hope they don't give this one to you, but if they do, you'll be ready. But boo, boo, boo on Pearson for doing this to us. All right, so if you rotate it this way, number 6, a wave is shown in the diagram below, which best describes this wave. The wavelength ends at the crest. The amplitude equals the wavelength. The amplitude of the crest equals the amplitude of the trough. The wavelength is the height of the crest plus the height of the trough. There's a ton of vocab in here. A ton. You need to know the difference between wavelength, which is crest to crest, or trough to trough. The distance up or the distance down, amplitude. And the best answer here is the amplitude of the crest, the distance to the crest, and the distance to the trough, that arrow distance is the same. That's the best answer. And it's still thundering. I'm doing all this on Tuesday and it was raining like crazy. All right, so delete this in your notebook. I will see you tomorrow. I hope you did well on your social studies TCAP, that you took it seriously, and that you did your very, very, very best and did not let this test trick you. Okay, I'll see y'all soon.